Hello guys, and in this lesson we are going to continue with graphs of functions and inverses. And our focus for this video will be on the exponential function. Let's start with a basic one. Before we are going to draw the function, let us first find its inverse. The 4 steps are: replace fx with y, step 1. Step 2, to create the inverse, we swap x and y's position. Step 3, we find y or solve y in terms of x. And what we have learned in the previous videos is how to use logs when it's an exponential function. So the base of the exponent becomes the base in the log, and the x becomes part of the answer. Actual exponent becomes the answer for this equation. And our last step was to rewrite y in the proper notation. I'm going to make use of the table method to solve or to find coordinates of the function. Now that I have coordinates for fx, I will plot it. So this graph now represents the exponential function of fx equals to 2 to the power of x. To find the inverse function, I can simply swap x and y in these coordinates. So there we have it. The first graph is the exponential function of fx, and the second graph is its reflection over the y is equals to x line. And this is the graph of the inverse of fx, which is the log 2x graph. Notice that this log graph is only on the right of the x-axis. Our second function that we will plot is gx is equals to 1/3 of x. Before we plot it, let's find its inverse. So I replace gx with y, step 1. Then for the inverse, I swap x and y's position. Now, in order to solve y, I need to use log laws. So the base of the exponent becomes the base in the log. And lastly, I need to rewrite y in its new notation. As stated in previous lessons, the value of the base in the log must always be positive. And in future lessons, we are going to learn more of the restrictions of this base value. For now, notice that it must always be positive. Therefore, bigger than 0. Using the table method, I have now plotted y is equal to gx. And to find the inverse function, I will simply swap the values of x and y in these coordinates. in order to find the inverse function. So the second graph now is the inverse function of the exponential function, where gx was a third to the power of x, and the inverse function is log a third x, and all that we did is we swapped these coordinates. So the 9 and the 2 became 9 and 2. So I swap x and y's position in all of these coordinates in order to get the coordinates of the inverse function. In the previous video we said that the inverse function is simply a reflection of gx over y equal to x.